Hello and welcome to the talk Modern ECU Development. My name is Michael Deubtzer and I'm manager of the product management team AUTOSAR tooling. Under the topic Modern ECU Development, we understand the change of mindset which is currently happening at many automotive companies, switching from a hardware vendor with some software to a software company with a hardware on wheels. Because this is a quite huge topic, we divided it in two parts. Now, I want to give you an overview which challenges on the AUTOSAR tooling we see as vector, mainly from the product line embedded software and systems. In the second part, my colleague Markus Oertel will show you what are the impacts on our embedded software in MicroSAR and adaptive MicroSAR. Now, starting with the challenges for the AUTOSAR tooling. Here we see three major challenges. The first one is our tools deal with heterogeneous systems. From a hardware perspective, several electrical control units get more and more integrated to central computation units. This means controllers having a system on a chip are used with, for example, a real-time controller and a performance controller, and sometimes even some special devices like for machine learning. Of course, all these different types of hardware or processors have different behavior in the execution of the application and different operating system functions. Like, for example, the scheduling has to be configured with our tooling, and we want to provide here the best user support. With a change to more capacity at the computation units, even the amount of software increases quite heavily. So this means there's a complex software existing from different applications like real-time applications for control loops, or even state machines, image processing applications which have a high demand on throughput, or even special algorithms for, like, for example, deep learning. And with the software, even different operating systems are used, like AUTOSAR Classic or Adaptive. The tooling has now the requirement to bridge between all these different kinds of technologies and provide the user their sufficient and good features in order to manage the interaction. The second challenge is the collaborative software development. When software becomes such a huge role in the development of new cars, then many companies and organizations work together in developing the software. This implies that software artifacts has to be shared and integrated afterwards again to be a part of the major software version. Therefore, even concepts like horizontal software integration are applied, where within one software layer, like the application software, several software parts are developed independently, are integrated first on a local scope, and then stepwise integrated to the complete control unit software. And even with agile development, feature-driven development approaches become more and more common, which means features are developed in parallel on different branches and have to be merged then together. And this implies even parallel changes of application software and basic software. And with the establishment of agile development, even continuous software development, which is the corresponding process for the software tooling, becomes critical. This means the intervals for software integration and software delivery become more and more shorter. And where in the past it was possible to have there some months, it's changed to days or even hours. And this, of course, even requires a high degree of automation, especially for continuous integration and continuous delivery for the tooling. What does this mean now in specific for the different challenges? On the one side, we see a strong trend to having a generic application software. This means an application software which is platform and project independent and allows you to reuse the save of the invest in the software. Of course, for a special control unit, a system design is required, which has an EE architecture and a software architecture corresponding to the selected platform, like AUTOSAR Classic Platform or Adaptive Platform. The API have to be selected and the ECU deployment has to be defined. For the integration and adaptation to the selected platform, we see the requirement to have there a good integrated development environment and good IDE, which supports these platform-specific adaptation and integration. As a result, from the development inside the IDE, an app package is created, which includes all the information which is required in order to integrate the software automatically. This includes, on the one side, the software components and the adaptive software components, the source code, and formalized integration instruction, telling an optimization process afterwards how different steps, which are normally done by a user in a GUI tooling, are applied automatically. Of course, a baseline or a runtime framework for classic or adaptive is required, where the application software can be integrated automatically. Then, due to the distributed development or across the complete world often, it's required to have a tooling which is, for example, available in the cloud or shared across different organizations. And here, especially a continuous integration solution is required in order to integrate the application software automatically into the basic software. As well, of course, for the adaptive side. And then together with the system design, the final ECU can be created, even virtual solutions, for example, with vVirtual Target or the real embedded code. And afterwards, Vector is even providing several solutions for the software testing and even for software management, like for variant handling and fleet management. At the end, the software will be provided to the car, for example, via over-the-air updates, where in the second part of this presentation, my colleague Markus Oertel will tell you a bit more. The second challenge, the collaborative software development, now has mainly an impact on how the software is developed in parallel and merged together. There often distributed version control is in the meantime used, like Git or Bazaar, for example, where the software or the release candidates are stored in a major branch, as we see here, and for development purpose, a development branch is created. Then each feature which is developed in parallel is developed in a feature branch, and after the development is done, the results of a feature branch are merged back to the development branch and then become a release candidate in the master branch. So this, in order to use this approach, even from the configuration tooling, a more text-based approach is required in order to have the possibility to compare the different configuration files. We see here the requirement to have a reasonable abstraction for our XML model elements in order to have there a user-friendly comparison of changes and even have a good comparison possibility and potentially even an easy or semi-automatized merge of the changed artifacts. Additionally, the tool chains are shared across different organizations. For example, one software company has two teams. One team is providing a basic software baseline, for example, baseline configuration. Another team provides some application software. Then there is another company B, which provides even some application software parts, and an OS vendor like Vector, for example, providing the Microsoft basic software. All of the different players here have the need to have automatized integration, potentially based on the software characteristics, even different integration pipelines. And afterwards, all of the different contributions have to be integrated together. And then, for example, all members get complete executable software, and for the local integration, only the committing partner get the software. So this means for each organization or integration layer, an individual pipeline has to be created and made available. And of course, even from licensing perspective, it's required to have a license concept which serves to have a sharing of a tool architecture or a tool chain. So what are now the major impact from the continuous integration or continuous delivery, which can be summarized as continuous software development? The intention of agile development is to have a fast feedback, and this is offered by continuous integration. So this means all the different steps still have to follow in a certain sequence, but simply there is a feedback loop which has a quite short time interval. In continuous integration, state of the art is already to have an automatic software compilation and a software linking. However, now this often steps like the software generation or the software configuration are applied manually and with a user interface. However, in order to have really a fast in a fast way and executable software, these steps like automatic software configuration and software generation have to be put also in the pipeline, and even as unit testing like smoke testing in order to see if the integration works until a certain degree fine. By the way, for automatizing this software configuration and even parts of the software generation for our AUTOSAR Classic solution, we have even with the DaVinci Configurator Pro a new option release, which is called Option CI, which allows to enable the optimization on local side or even on server side. Next maturity level for continuous software development is continuous delivery. This means the software is even tested automatically and has at the end a quality where theoretically it's possible to ship the software and provide it to the car fleet. This implies beside continuous integration, even automatic functional test, automatic non-functional test, like testing the timing behavior, automatic regression testing, in parts even automatic acceptance testing, the product packing, and putting the software to the staging area where finally afterwards the person can then decide to provide it to the car fleet, where then over-the-air updates come into the role. CI mainly brings benefit for the internal software development, because software developer get fast and testable version and then can apply changes in case of misbehavior. Continuous delivery, on the other side, is a real benefit for the end customer, because software features can be made available much faster and even used by end customers. So what is now the implication and the impact on the tooling side? So one step back, when we see today or past development, it's often more a role-based model for tooling. This means there are dedicated roles or users which using certain expert tools, like the system architect uses Provision, the application software developer uses DaVinci Developer and in parts DaVinci Configurator Pro. The integrator uses DaVinci Configurator Pro for integrating the application, and vVirtual Target for generating a virtual executable, and a tester who uses KNU for the testing purpose. These steps are all mainly GUI-based. However, the drawback for agile development and continuous software development, as we see here, the steps are sequentially, and due to the defined handshake with certain artifacts, the different roles are dependent on each other, which results also in a long total duration for providing new feature or developing a new feature from beginning to the end. This changes with CX or continuous software development. Taking now as an example the application developer. Now we expect the developer mainly uses an IDE and has there in a textual way the possibilities to define formalized automation instruction. Potentially even a graphical tool is used for as DaVinci developer for visualizing the software architecture. Then the results are checked in a version control system, and CI system like Jenkins or TeamCity triggers the CI or CD pipeline. Of course, a baseline is required, which includes the basic software with some pre-configuration, which then allows to automatically integrate the application software. In the pipeline itself, several work steps are executed, like an input validation. Are all artifacts valid according to schema, for example? Then the configuration, the integration is applied automatically, mapping the application software to the basic software. The generation and the build is created even for virtual testing, for example. Test and verification is automatized. Non-functional test for timing, for example, is applied with TA inspection, allowing to analyze timing traces. And at the end, some reporting is done, and potentially even code checks are applied with, for example, Square. Of course, this pipeline is not executing on a local PC, but on a server system, so that the user is not blocked by the performance impact. And sometimes even external mainframe is used in order to scale up the capacity of the pipeline, quite flexible, depending on the requested or committed artifacts and triggered jobs. This way of using the tools requires some changes or has some certain requirements on the tooling. On the one side, it's all of these steps, of course, are automatized. So this means the tool have to use a good scripting possibility, which allows to make model modification, import and export, or even execution of helper functions possible. On the other side, when everything runs automatically, a good reporting is required in order to give confidence in the automation, but even in case of errors or warnings, easily detect where the problem occurred. Of course, it's also not necessary to cache intermediate results between the work steps, because, for example, in a case a build fails, then it has to be reproduced, often on a local site with the tools opened and with a GUI. And in this case, it's time-consuming to potentially run the pipeline from beginning, but the experts simply now want to take the input results from the failed work step and start from there with the GUI. And of course, caching of work results here even brings a big benefit in performance reasons, because in case input artifacts haven't changed, a work step simply can be skipped. Of course, also the GUI is still required here in one side for setting up this pipeline, but even for debugging purpose, as I have mentioned. So in general, this concept of continuous integration and continuous delivery brings even a big improvement for preventing repetitive tasks or automatizing them, and especially it enables the engineers to work independently. So as a summary, we are working on the challenges to provide the best tooling for heterogeneous system, collaborative software development, and continuous software development. And of course, we are interested in exchanging with you. So what are your perspectives, and what do you think about our solutions for the future toolchain? We will introduce a new technology, the AUTOSAR development framework, beginning with 2021. This allows, on the one side, a better collaboration support for automotive software development in a collaborative way. We will provide a new product for continuous integration and continuous delivery for AUTOSAR systems. We will provide an IDE support for developing AUTOSAR Classic and Adaptive cross-platform systems. And even with a new tool architecture, there will be significant performance improvements. For this week, don't miss the chance to visit us on our virtual booths for AUTOSAR and ECU software. There we will have 3 presentations. On the one side, we will show you the option CI for automatizing application software integration for AUTOSAR Classic. We will show you how timing, tracing, and timing analysis can be done with TA inspection. And we will introduce you our AUTOSAR adaptive tool solution. Now we are at the end of my presentation. Thank you very much for joining this talk. And I am now looking forward to your question. Please also use the Contact Me button if you want to go in a bit deeper discussion and want to exchange on your perspective and discuss a bit more our solution. Thank you very much.